The approximate radius of the solar system is 30 trillion kilometers. During the whole time of exploration of this space, mankind has found 316 minor planets and 8 main ones that everyone knows about. But no is too big a word. In most cases, we only know what these planets look like and at what distance they are from the Earth. Everything else is just our assumptions. To replace speculation with facts, humanity regularly sends space research probes to other planets. One of the most significant and truly epical missions was Cassini-Huygens, the purpose of which was to study Saturn and its satellites, namely the search for answers to the questions: what threat are the rings of Saturn? What does the surface of the planet actually look like? And, most interestingly, is life possible there? October the 15th, 1997. Cassini was launched into space by NASA, a high-tech object the size of a school bus and worth $3 billion. In order to accelerate such a device, it was necessary to use the gravitational field of 3 planets. It passed next to Venus twice, in 1998 and 1999. Then, at a speed of 69,000 kilometers per hour, it rushed near the Earth, and only a year later, in 2000, it picked up the required speed, passing by Jupiter. It was not so easy to accelerate the device weighing 5,710 kilograms, but with each new month, it became easier. After all, more than half of Cassini's weight was fuel, the reserves of which were decreasing every day. Having flown 3.5 billion kilometers, Cassini approached the rings of Saturn. In photographs, they appear smooth and gaseous, but in reality, these are billions of space debris pieces ranging in size from a fingernail to a huge building. And given the speed at which the Cassini was moving, a collision with even the smallest fragment was enough for the entire apparatus to be instantly destroyed. But luckily, Cassini made it through the rings safely, and it sent unique footage to Earth, which helped make several amazing discoveries. For example, scientists used to think that each one of the rings of Saturn is the same, but Cassini's pictures showed that all the rings are different, even those that are close to each other. In addition, scientists were able to find out that the thicker the rings, the older they are. Thanks to gravitational measurements during the maneuvers, Cassini found that the approximate weight of Saturn's rings is 15 quadrillion 400 trillion tons. Most likely, Saturn's gravity is tearing apart icy moons and comets. From their debris, the rings are formed. But in 2004, Cassini photographed something else that especially interested scientists. In one of the outer rings of Saturn, they documented the presence of small moons. Scientists have taken pictures of the particles they're composed of, collecting and scattering nearby small satellites. In other words, Cassini managed to photograph the moment of the formation of a smaller system within a system. This is an absolutely grandiose find. According to scientists, thanks to the observation of these processes, it's possible to obtain information about the formation of our solar system. In the end, we'll be able to find out how planets are formed in protoplanetary disks. And one more shocking discovery. Saturn devours its own rings. From the rings to the surface of Saturn, there is a real shower of water droplets and dust. And shower is saying too little. This is a real cosmic hurricane, because every second, Saturn devours up to 45 tons of ring matter. During its mission, Cassini documented the dynamics of the change of rings. Rings D and C are going to disappear. But by human standards, Saturn will not devour its rings soon, for this will take at least 700,000 years. But the main goal of Cassini, of course, is not the rings, but Saturn itself and its satellites. And the resulting photos of the planet did not disappoint. Cassini managed to record an incredible storm at the planet's north pole. Its diameter is 32,000 kilometers and its speed is 150 meters per second. It's scary to even imagine how it looks from inside. And what is phenomenally different about it, this storm has a perfect hexagonal shape. This storm is 50 times the size of a hurricane on Earth, and even the walls of this vortex go deep into the atmosphere at up to 100 kilometers. Research into the origin of this storm is still ongoing. In total, Saturn has 82 known satellites with a confirmed orbit, each of which is somehow different. For example, Hyperion is a natural satellite, looking like a 360-kilometer potato. The pictures showed that it was all composed of rocks and ice. Hyperion looks like it survived a terrible bombardment, but the porous surface is not explained by this, but by the extremely low density of the planet. Because of this, only 60% of the planet is composed of ice, rock, and metal impurities, and the rest of its internal volume is made up of cavities, which we also see in Cassini's photographs. Another satellite of Saturn, Tethys, raises a lot more questions. Cassini took color photographs which clearly show unidentified red stripes on the surface of the satellite. Their origin is a mystery. They look as if someone drew them. One of the versions is the huge cracks that formed on the satellite, as if something is splitting taffia from the inside. But what is it? Hot lava or unique chemical components? So far, it's not been possible to find out. As if something is splitting Tethys from the inside. But the most interesting is the most important satellite of Saturn, Titan. To investigate Titan, a specially designed Huygens probe was placed in Cassini. On December the 25th, 2004, Cassini launched Huygens into the hazy atmosphere of Titan. The probe entered the atmospheric layers of the satellite. Due to the terrible friction, Huygens' heat shield warmed up to 1,500 degrees, but the probe survived and landed safely. Before Cassini's trip, no one could even imagine what surface the probe would land on. But all signs of landing indicated that Titan's surface is a hard surface, beneath which is a soft and light substance. Further discoveries were truly amazing. It turned out that Titan is the best factory known to man for the production of organic compounds. Almost the entire satellite is covered with a layer of frozen hydrocarbons that resemble gasoline. In other words, if humanity dug a mine on Titan, then we'd be able to provide the entire Earth with oil for thousands of years. But that's not all. The most important discovery was ahead. Judging by all the data obtained by Huygens, Titan's atmosphere is predominantly nitrogen, just like the atmosphere of our planet. That, together with complex carbon compounds in Titan's foggy atmosphere, allows to suggest that Titan is a suitable place for the existence of life. One minus, it's too cold on it. That, however, does not interfere with the existence of deep lakes thousands of years old. True, if on Earth reservoirs are filled with fresh or salt water, then on Titan they consist of methane and ethane, with a temperature of about minus 180 degrees Celsius. You'll hardly want to swim in there on vacation with your family. Huygens' expedition made it clear that Titan is the most Earth-like object in the solar system known to us. There's also lakes here, seas, flowing rivers, rainfalls. There's even a change of seasons here. True, each of them lasts for 7 Earth years. The potential for exploring this planet is very high, and in the future, if humanity does begin to colonize, Titan will most likely be used as a galactic station for the extraction of resources. However, the discoveries on Titan are not the most astounding ones that Cassini made. By pure coincidence, scientists came across other information. Saturn's other moon appears to have life. On Christmas Day, December the 25th, 2021, astronomers held their breath as an Ariane 5 heavy rocket carried the James Webb Space Telescope into space. After that, it took 30 days for the telescope to travel 1.5 million kilometers and reach its operational location. It would take another 6 months for engines to set up instruments and align the telescope's 18 gold hexagonal mirrors. But on July the 12th, 2022, it sent back its first images that stunned everyone. One of those images now holds the record for the deepest view of the universe ever taken, and shows the galaxy cluster named SMACS 0723 as it appeared 4.6 billion years ago. The cluster of galaxies is so heavy that it warps the light from much more distant galaxies behind the cluster. But this image reveals so much more than the original Hubble Deep Field image, and it's just a tiny sliver of the vast universe. One of the big surprises is that the galaxies caught in the image are much more massive, and the other is that they are far more structured than previously imagined. In other words, no one believed these galaxies could be so well organized in the early universe. Is this the reason that a well-known science writer, Eric J. Lerner, believes the newly revealed galaxies in the Deep Field image from the James Webb Space Telescope prove there was no Big Bang, and the universe is much older and static? Lerner wrote a book in 1991 called The Big Bang Never Happened, and instead believes in something called plasma cosmology. Of course, many online channels jumped at the chance to parrot the false information. But is there any truth to Lerner's theory? While it is true that some unexpected images of galaxies came back from the $10 billion James Webb Space Telescope, the Big Bang theory is still holding up strong. As the late great Carl Sagan once said, extraordinary claims require extraordinary evidence. So far, Mr. Lerner hasn't provided any solid evidence to support his theory. Despite the false rumor that the Big Bang never happened, because of the amazingly detailed JWST Deep Field image, the other images from the Space Telescope were equally incredible. One of the most breathtaking and unexpected images was taken of the planet Jupiter in August 2022. Giant storms, powerful winds, and auroras can clearly be seen, and it certainly looks like Jupiter has a whole lot more going on than previously thought. In the photo, you can see Jupiter's dust rings and its moons, Amalthea and Adrastea. Compared to the first image taken of Jupiter, taken by Andrew Ainsley Common in Ealing, London, on September 3rd, 1879, using a 91cm reflector, this image truly showcases the imaging power of the James Webb Space Telescope. As beautiful as the images look, the colors don't match what the human eye would see, since our eyes aren't capable of picking up infrared radiation. What you're seeing is the result of image processors mapping longer infrared wavelengths to the red end of the visible spectrum and shorter wavelengths towards the blue spectrum. This mimics how the human eye perceives visible light. This is the JWST image next to the latest Hubble telescope image of Jupiter. The Hubble image definitely looks more natural to the human eye, but the much higher details in the image from the JWST can clearly be seen. But this isn't all the mega billion-dollar telescope has imaged and discovered. One of the first targets of focus for the Webb Space Telescope was the exoplanet WASP-39b, which lies in the Virgo constellation around 700 light-years from Earth. This gas giant planet is a bit bigger than Jupiter and orbits what astronomers call a G-type star. This hot gas giant, much like Saturn, orbits close to its star, giving the Space Telescope the perfect target to image its atmosphere. NASA's Hubble and Spitzer space telescopes revealed the presence of water vapor, potassium, and sodium in the planet's atmosphere. Despite this, no one was absolutely sure about the findings. However, the Webb telescope's super-sensitive infrared instruments have now confirmed these things and the presence of carbon dioxide on this planet as well. Finding carbon dioxide might not sound like the most groundbreaking thing, but it's important because it's a very sensitive measuring stick for understanding heavy elements in the atmospheres of giant and rocky exoplanets. The James Webb Space Telescope also used its near-infrared spectrograph on Mars on September 5, 2022. The NearSpec module can easily detect the spectral signatures of carbon dioxide, water, and carbon monoxide. Not only that, but a preliminary analysis of a spectrum with a rich set of spectral features can contain information from dust and icy clouds to even what kinds of rocks are on the planet's surface. With this kind of power, the James Webb Space Telescope is just getting started. Recently, the Webb telescope focused its powerful gaze towards Neptune and grabbed this ghostly image of the planet and 7 of its 14 known moons. Keep in mind that Neptune is 30 times farther away from the Sun than the Earth and lies in the dark region of our solar system. And if you're wondering why Neptune's moon Triton is shining like a bright star in this image, it's because it's covered in a frozen sheet of condensed nitrogen that reflects around 70% of the sunlight that hits its surface. These images look a lot different than the images we're used to of seeing Neptune as an icy blue orb. The difference is these images were taken with Webb's near-infrared camera, range from 0.6 to 5 microns. This is why Neptune doesn't look blue to the Webb telescope. Another thing is that the methane gas of Neptune strongly absorbs red and infrared light, and this makes the planet very dark at near-infrared wavelengths. JWST also grabbed a few new images of Stephan's Quintet, a group of galaxies that are close enough together that they give astronomers a front-row seat to galactic mergers and interactions. In other words, Stephan's Quintet is a sort of cosmic laboratory that's going to allow astronomers to see how galaxies merging together trigger the formation of stars. The image shows clusters of millions of young stars and sweeping tails of gas and dust being pulled on by the gravitational interactions of the galaxies. The most dramatic part of the composite image is the huge shockwave of the galaxy NGC 7318b as it smashes through the cluster. But if you want to see something really incredible, then take a look at the NearCam image of the Tarantula Nebula. It's a mosaic image that stretches 340 light-years across and shows tens of thousands of young stars that have never been seen before because they're shrouded in cosmic dust. The most active region in the middle sparkles with young stars that appear blue. To the upper left of the young star cluster is an older star shining brightly and displaying the distinctive 8 diffraction spikes that's an artifact of the Webb telescope structure. Farther from the core of the young stars, cooler and much more dense gas takes on a reddish rust color, complex hydrocarbons that will form future stars. New images coming from the James Webb Space Telescope really showcase its power. This is the heart of the Phantom Galaxy imaged with the telescope's mid-infrared instrument. In this incredible view, masses of gas and dust are sharply highlighted within the galaxy's arms, with the dense cluster of stars at its core. Another jaw-dropping image is the Cosmic Cliffs image from the JWST's NearCam. The image reveals star birth that couldn't be seen before thanks to the near-infrared camera. The Cosmic Cliffs is a gigantic gaseous cavity about 7,600 light-years away from us. What looks like steam that appears to rise from the celestial cliffs is actually hot ionized gas and dust that's streaming away from the nebula due to intense ultraviolet radiation. Bubbles and cavities are blown into the gas and dust from the intense radiation and stellar winds of newborn stars. These images are certainly impressive, but what about all this talk of James Webb Space Telescope being able to look back in time? In July 2022, after the first images were shown to the world, the James Webb Space Telescope found what some astronomers are calling the oldest galaxy ever seen. They named it Glass Z13, and its age has been dated back to 300 million years after the Big Bang. This galaxy is so far away from us that it's taken 13.4 billion years for its light to reach us. But because of the expansion of the universe, the distance between us and the galaxy is now a mind-boggling 32 billion light-years away. Eventually, in the very distant future, the amount of galaxies that we can see, including Glass Z13, will grow far less over time as they slip past the observable edge of the universe. The discoveries have been incredible so far, and from estimates made by engineers, the telescope should have enough power to work for about 20 years, opening the universe to us. But this is as long as the mirrors stay undamaged. The James Webb Space Telescope has already sustained permanent damage when a micrometeoroid struck one of the mirrors. The small rock that hit the telescope in May 2022 caused significant and uncorrectable damage. Thankfully, we don't have anything to worry about, because the damage is small enough at the full telescope level that it's not going to cause a big problem. NASA is hoping the micrometeoroid strike was a rare thing. Extreme travel is always dangerous. Deadly currents and whirlpools on rivers, avalanches of ice on mountains. But what if a wall of fire, more than 500 million kilometers in size, gets in the way? Although impossible on Earth, this can happen in space, and the space probes Voyager 1 and Voyager 2 might have recently encountered such an obstacle. Its temperature exceeded that of fires on Earth dozens of times. 45 years have passed since the launch of Voyagers from Cape Canaveral. They've visited 4 distant planets, taken vivid pictures, and conducted hundreds of scientific investigations. Then the probes went beyond the solar system, where a real red-hot hell awaited them. And this was not the only eerie and sometimes delightful adventure on their way. But recently, Voyager 1 started sending data that had scientists stumped. So what did scientists learn about the Voyager's adventures so far? Did the spacecraft manage to make it over the nightmarish wall of fire? And why would the entire journey of the probes in interstellar space be accompanied by the gentle rustle of rain? For almost half a century, probe equipment that made it all the way beyond the solar system has been working well almost all the time. It withstood the space environment with its nightmarish radiation, low temperatures, dust as sharp as needles. This seems unbelievable, but it was possible thanks to the excellent level of protection the space probes have. They're equipped with multi-layer thermal insulation, heat shields, and plastic jackets. Individual elements of their defense line are quite simple. For example, shortly before launch, strips of kitchen aluminium foil were glued to some of the cables as a protection against radiation, and it worked perfectly. The amount of work and people put into the development and implementation of the project is about 11,000 years. This is equivalent to a third of the effort expended to build the Great Pyramids of Giza. When the probes were launched into space, they headed for Jupiter, Saturn, Neptune, and Uranus. There, Voyagers took many extraordinary images. In addition to the iconic pale blue dot and volcanic eruption on Jupiter's satellite Io, there are less known but stunning images. Check out this tete-a-tete of the Earth and the Moon. The image was taken as Voyager 1 headed toward Jupiter. In this image, both our planet and its satellite look like 2 crescents moving somewhere in the same direction. And here, you can see the edge of Titan's disk, Saturn's largest satellite, captured by Voyager 2. But why does it come in 2 colors? It's just that the mysterious haze at an altitude of a couple hundred miles from the atmospheric surface looks blue. The atmosphere itself appears to be orange and is mostly composed of nitrogen with a mixture of methane and possibly hydrogen and carbon compounds. It's believed that this is what the Earth's atmosphere was like prior to the emergence of life. After flying around the planets, Voyagers turned off their cameras and some other devices to save energy. But other devices were still able to conduct research, sending data back to Earth. Without much trouble, the probes reached the edge of the solar system, and then the edge of the heliosphere, filled with solar wind. They entered the heliopause region, where the pressure of the solar wind and the interstellar plasma is equalized. In this mysterious place, which scientists had previously studied only through simulations, the probes made surprising discoveries. Researchers had expected the magnetic field of the galaxy near the heliopause to be tilted towards the solar magnetic field. But the probes found no change in the direction of the magnetic field, and the particle density was 10 times greater than in the solar wind. Flows of solar and interstellar particles collide in that region at unimaginable speeds. It makes them glow and form a wall of fire. That's what astronomers call the phenomenon, although it's not known for sure if it's a kind of fire we are familiar with, and if it's really burning there. But it's clear that the plasma at the outer boundary of the heliopause is about 30,000 to 50,000 Kelvin. At first glance, it seems impossible to go through this region undamaged. But the probes succeeded. The plasma turned out to be very thin, much smaller than the air on the surface of the Earth, so it didn't heat up the probes to critical temperatures. Studying the red-hot wall is very important for scientists. After all, it is the heliopause that is the solar system's last line of defense against dangerous cosmic rays and interstellar dust. The heliosphere blocks approximately 70% of the deadly radiation coming from deep space. Without it, life on Earth would have been impossible, and the wall of fire that Voyagers discovered most likely plays an important role here as well. But we still don't know whether astronauts will be able to overcome it during interstellar missions in the future. According to astrophysicists at Boston University, it largely depends on the shape of the heliosphere. Is there some safe loophole in it for Starship crews? Scientists used to believe that the heliospheric bubble was shaped like a comet's tail. But new research suggests that it might have the shape of a donut or a croissant. If so, it'll have gaps in it, which astronomers will have to find. As the probes entered interstellar space, they recorded different sounds. We wouldn't have heard them, but the instruments picked up the noise and transmitted it to Earth. At first, scientists couldn't determine their source. Later, they've come to the conclusion that it's the sound of gas in interstellar space. And there's much more of it than previously thought. In the meantime, the spaceships continue to transmit valuable data to Earth, although it takes about 20 hours for the signal to reach us. Besides, not everything ran smoothly. Voyagers have had problems on more than one occasion. Back in April 1978, Voyager 1's main radio receiver malfunctioned. Since then, it's been operating on a backup receiver. Recently, something strange started to happen. Voyager 1's telemetry began sending absurd data back to Earth. Telemetry is the measurement and collection of information to provide to the operator or user. The probe continued to keep its antenna pointed at Earth. The mission specialists investigated the situation and identified the source of incorrect telemetry. It turned out that the information was transmitted through a computer that stopped working many years ago. It was corrupting the data. Then a command was sent to switch to the right computer. After that, everything went back to normal, but the cause of the malfunction is still unknown. In addition, the Voyager's power sources are getting cooled and depleted. They're no longer able to fully maintain the temperature of the equipment. However, NASA engineers claim that the spacecraft still has enough fuel to keep its instruments running until at least 2025. One day we'll lose contact with the Voyagers, but they'll continue their journey through interstellar space, mostly among void. Only in about 30,000 years will the Voyagers pass through the Oort cloud, a shell of comets and icy debris orbiting the solar system. And only in about 40,000 years, Voyager 1 will be closer to the star Gliese 445, 17.6 light-years from Earth, than to our Sun. By that time, Voyager 2 will pass 1.7 light-years from the red dwarf star Ross 248 of the constellation Andromeda. Looking even further into the future, in about 230 million years, the solar system and Voyagers will make a complete revolution around the Milky Way. It's impossible to predict what will happen to Earth by then. But can the probe survive that long in interstellar space? Scientists believe that it mostly depends on the amount of dust in the Milky Way. This dust flies at several miles per second, like a nanometeor shower. The dust particles slowly erode the shell of the probes, and even a dust particle the size of 1,000th of a millimeter leaves its microscopic mark on the ship upon impact. Scientists have repeatedly modeled the trajectories of the probe, their encounters with dust clouds, and possible damage. Calculations by Nick Oberg of the Kaptein Astronomical Institute in the Netherlands have shown that the Voyager Golden Records have a chance of surviving the longest. Because of how valuable information they carry about Earth for a possible alien encounter is, these records have great protection. Underneath the gold cover of the gold-plated discs is an aluminium coating, and underneath that is a copper base. The half-life of plutonium-238 in the Voyager nuclear reactor is 87.7 years, and in a small area of the coating of uranium-238, it is 4.5 billion years. We can hardly imagine such a distant future, but scientists have painted us a rough picture. At that time, the Milky Way should already collide with the Andromeda Galaxy. The spiral shape of the Milky Way would be severely deformed and possibly completely destroyed. The collision could eject the probes from the new monster galaxy. The chance of this event is estimated as 1 in 5. In this case, the main threat to the Golden Records in intergalactic space would be cosmic rays and strange hot gas molecules. If the Voyagers remain inside the unified galaxy, their fate will depend on the same dust. If the probes get into a dense dust cloud, they'll have an enormous chance of collapsing. But there may not be much dust, because star formation at that time will practically stop. Voyagers will drift through a completely unrecognizable galaxy, free from main sequence stars. In space, there'll be almost only black holes and the remains of stars, white dwarfs and neutron stars. there will be complete darkness everywhere. Only extremely rare flashes of supernovae will occasionally illuminate the sky. In this inhospitable world, voyagers will be able to wander for trillions and trillions of years. Meanwhile, other probes will explore the outskirts of the solar system and interstellar space. There are already interesting designs for future spacecraft that will venture into interstellar space. NASA has created the Interstellar Probe concept. It's planned to be equipped with many modern and reliable devices. Among other things, the probe will be able to thoroughly study the solar wind and its use for sailing spacecraft. In 2018, NASA has successfully launched the Parker Solar Probe to revolutionize our understanding of the Sun and space weather. The Parker Solar Probe was designed to become the first spacecraft to enter the Sun's atmosphere. It's the size of a small car, and it weighs 685 kilograms. The spacecraft has several important instruments on board. The Solar Wind Electrons, Alphas and Protons Investigation, or SWEEP, will sample particles in the solar wind. The instrument has 4 sensors that calculate the abundance of particles. The Wide Field Imager for Solar Probe Plus, or WISPR, is a telescope that can take 3D images of our star's corona and any structures that pass by the probe. Another tool that Parker is equipped with is called Integrated Science Investigation of the Sun. It's made of 2 separate instruments, each having a different energy range. The instrument can weigh highly energetic heavy ions, electrons, and protons moving through the Sun's atmosphere. Lastly, made of magnetometers and electric field antennas, the Parker Solar Probe will use Electromagnetic Fields Investigation tool to analyze magnetic fields, radio emissions, and density of the Sun's corona. But how can the Parker Solar Probe get so close to our star without melting? To study the Sun under such extreme conditions, the probe and its instruments are equipped with a super reflective coating and a shield that measures 2.3 meters in diameter facing the Sun. The shield, called the Thermal Protection System, is made of 11.5 centimeters of thick carbon composite. This makes the Parker Solar Probe capable of withstanding temperatures outside the spacecraft that reach roughly 1,370 degrees Celsius. And even though that might not seem like enough protection, the density of the Sun's corona isn't high, and not many particles actually hit the probe. The spacecraft and its instruments are also strategically placed in the center of the shadow that's coming from the shield. The Parker Solar Probe also has sensors to let it know that the heat shield has been adjusted when needed. Another level of protection is located on the inside of the probe. Parker has a dual array of solar panels and a smart cooling system. The cooling system circulates water behind the solar cells where it gets heated. Then this same water is pushed down into the radiators where it's cooled. All this makes the Parker probe resistant to heat and radiation like no other space probe before it. And even with that level of protection and low density of the corona, Parker can only stay in this layer of the Sun for a few hours. But how in the world is it possible to even send a probe towards the Sun? It's 150 million kilometers away and would take forever to get there. Reaching the Sun isn't that simple. When a spacecraft is launched into space, whatever velocity rockets give it will be superimposed on top of Earth's orbital velocity, meaning that we can either cause the spacecraft to have more or less orbital energy than the Earth does. We can either boost it to a higher, less tightly bound orbit with respect to the Sun, or deboost it to a lower, more tightly bound orbit. Most of our space probe missions use planetary gravity to accelerate spacecraft and give them more orbital energy. But with Parker, scientists needed to do the opposite, make it lose orbital energy. The Parker Solar Probe has used multiple slingshot orbits using Earth, Mercury, and mostly Venus to enable it to get this close to the Sun. And each time it goes around the Sun, the probe picks up an insane amount of speed. Astronomers call it gravity assist, and it helps Parker narrow its orbit around the Sun and bring its perihelion about 6.4 kilometers closer. So, did it actually touch the Sun? Unlike Earth and some other planets, the Sun doesn't have a solid surface, but it still has a boundary. The point where the Sun's gravity and its magnetic forces keep in the solar material is called the Alfvén critical surface. According to astronomers' calculations, it should be anywhere between 10 to 20 solar radii from the surface of the Sun, which is roughly 7 to 13.8 million kilometers, and scientists believe that it marks our star's boundary. With every gravitational maneuver, the spacecraft narrowed its distance to the Sun, and as it did so, astronomers searched for signs that the Parker Solar Probe had reached the critical surface. So what happened when NASA's spacecraft arrived at its destination? As the probe passed through a pseudo-streamer or a loop-like structure in the corona of the star, the whirlwind of particles started moving much slower, limiting the impact on the probe. This meant that the magnetic fields were dominant in that region, so that no particles could escape it. It was the proof that the Parker was inside the Alfvén critical surface. The spacecraft then recorded a video of coronal streamers moving past it. It was the first time scientists were able to see these mysterious objects from up close. The data collected from the probe shows that switchbacks or zigzag structures in the solar wind are quite abundant close to our star. Before, astronomers thought these zigzag structures were rather an abnormality occurring near the Sun's poles only. But the spacecraft helped scientists conclude that these structures originate in the solar surface and are quite common. Parker has also discovered that the critical surface was 18.8 solar radii from the solar surface, and it took 8 flybys and over 3 years to finally get there. But this wasn't the only discovery made by Parker that fascinated scientists. Multiple flybys near Venus have opened more opportunities to study this hot world. Until recently, astronomers didn't know exactly what the planet's surface looked like. Usually it's covered with thick clouds, so a big part of the visible light coming from the surface of Venus is shrouded from sight. Parker didn't only manage to record the atmosphere of our Sun, but it also captured Venus's surface from space. During its flybys, Parker used its wide-field camera to take images of the entire night side in wavelengths of the visible spectrum. For the first time, scientists were seeing Venus's surface in visible wavelengths from space. Even on the night side, the surface of the planet is roughly 475 degrees Celsius. It's so hot that you could see its rocky surface glowing. So far, the spacecraft has approached the Sun at a distance of 8.5 million kilometers from its surface. The previous record was set by the Helios 2 spacecraft in 1976, and the distance was only about 43.5 million kilometers. Aside from that, Parker is also breaking space speed records. During one of its approaches, it was moving at about 700,000 kilometers per hour. At that speed, it would take Parker about 1 second to get from Philadelphia to Washington, D.C., or less than a minute from New York to Tokyo. This makes it the fastest human object ever made. Scientists haven't found answers to all their questions yet, but as the spacecraft enters the Sun's atmosphere again and again, we'll find more clues. The Sun has an 11-year activity cycle during which its stormy behavior intensifies and then settles back down to a minimum. And because it currently ramps up, its corona will expand, giving the Parker probe even more opportunities to enter it again and stay in there for a bit longer. Eventually, the spacecraft will get as close as 6.1 million kilometers from the Sun's surface. This is just within the orbit of Mercury, which is roughly 7 times closer than any spacecraft has ever approached the Sun before. The Parker Solar Probe hasn't finished its mission yet. NASA wants to send the spacecraft deeper into the solar atmosphere to collect more data about how our neighboring star works. It'll help better understand the phenomena happening inside and around the Sun. The Sun is the only star we can study from such a close distance and the only one known to us that can support life. So if we understand it well enough, we can succeed at searching for life outside our solar system. Eventually, the probe and its instruments will start failing, and the spacecraft will melt into a charred piece of metal that'll keep orbiting the big glowing ball of hot plasma. Its journey will come to an end, but until then, it could surprise us with more fascinating discoveries. In the summer of 1964, NASA developed ways to study the outer planets of the solar system in the NASA Jet Propulsion Laboratory. Engineer Gary Flandreau predicted that by the end of the 1970s, there'd be a rare alignment of the planets Jupiter, Saturn, Uranus, and Neptune that only occurs once every 175 years. This alignment of the planets would allow mankind to visit all 4 planets during a single mission. The flight would change its trajectory at each planet and increase the speed of the probe enough to reach the next point in its flight path. Gravity maneuvering, or slingshotting, is when a spacecraft is pulled by a planet's gravity and increasing speed as it shoots around the planet, saving tons of energy and time. As an example, flight to the farthest planet, Neptune, could only take 12 years instead of 30. The Mariner Jupiter-Saturn project began in early 1972 at a cost of $360 million. In March 1977, just a few months before launch, due to the mission's importance, the probes were renamed Voyager 1 and Voyager 2. The Voyagers were equipped with computers that could be reprogrammed, allowing researchers to change programs and fix any problems on the fly. On August 20th, 1977, Voyager 2 was the first sent into space, 16 days before Voyager 1 would be launched. But because it was on a trajectory that took longer to reach Jupiter and Saturn, Voyager 1 would eventually pass it. Since 1962, there's been interplanetary missions to study Venus, Mars, and Mercury, with missions lasting up to 3 years. But the probes would need to last long enough to be part of the Grand Tour project at NASA, which needed 2 probes to study the 4 gas giants, Jupiter, Saturn, Uranus, and Neptune. But it was later suggested that Voyager 1 and 2 visit only 2 planets. Information in the press spread saying that only Jupiter and Saturn would be visited, reducing the overall cost of the project. Experts looked at over 10,000 trajectories before they chose 2 that would allow them to fly by Jupiter's largest moon, Io, and then Saturn and its largest moon, Titan. This route also gave the spacecraft the opportunity to continue towards Uranus and Neptune. The thought of extraterrestrial civilizations intercepting these probes was on the minds of researchers. American astronomer Carl Sagan, along with his team, created a golden record, with 115 images encoded in analog form, spoken human greetings in 55 languages, a variety of natural Earth sounds like wind and thunder, sounds of animals like birds and whales, and different music from around the world.
Hello from the children of planet Earth.
Which probe made the first planetary mission? The original mission plan was for the Voyagers to operate and last only 5 years. It would be long enough for them to study Jupiter, Saturn and its rings, and the 2 planets' largest moons. However, as the mission continued, the ambitions of scientists grew, and the Voyagers outperformed well beyond what was expected. On March 5, 1979, Voyager 1 was 173,983 miles away as it approached Jupiter and was able to snap images of its moons Io and Europa. And although Jupiter has been one of the most studied planets in our solar system, new photographs gave researchers unseen angles and more information about these planets as if they were new worlds. The new images of Jupiter's closest moon, Io, had yellow, orange, and brown surface colors, showing scientists evidence of volcanic rock. At least 8 active volcanoes were spotted on Io, shooting material into space, and stunning images of this were captured when Voyager flew by. Io turned out to be the most volcanically active body in the solar system. A little over a year after launch, Voyager 1 approached Saturn on November 12, 1980. Expectations were greatly met, and researchers were able to expand their understanding and knowledge of Saturn. 3 new moons were discovered: Prometheus, Pandora, and Atlas. But the biggest accomplishment was getting new information about Saturn's largest moon, Titan. It's the only moon in the solar system that has a thick atmosphere. Similarly, it was discovered that the upper layers of Saturn's atmosphere consists of 7% helium, and the rest is hydrogen. Voyager 1 also discovered Saturn's G-rings, disc-shaped plains made of ice and dust. Another interesting discovery was Saturn's 6th largest moon, Enceladus, which was found to reflect more solar light than any other object in the solar system because of the fresh, clean ice covering its surface. Images were captured that showed its crater-ridden landscape, indicating some geological activity under the surface that could be a source of heat for a liquid ocean. But Voyager 2 was about to make some discoveries of its own. On July 9, 1979, Voyager 2 made its closest approach to Jupiter and snapped this amazing photo of Jupiter and its moon Io, casting a shadow on the gas giant. On August the 25th, 1981, after successfully arriving at Saturn, the probe snapped images of the gas giant's rings and moons. It was clear at this point that Voyager 2 could now fly to Uranus with all its instruments remaining functional. NASA asked for more money and instructed the NASA Jet Propulsion Laboratory to extend the Voyager 2 mission to Uranus and Neptune. On January the 24th, 1986, the Voyager 2 probe approached Uranus at a distance of 50,600 miles above the icy cold cloud tops and gathered data that revealed 2 new rings, 11 new moons, and recorded the surface temperature of Uranus at a chilly -353 degrees Fahrenheit. Uranus rotates at an angle, and its magnetic field is displaced from the axis and plane that all other planets are found in. The data also showed that both of Uranus's poles have the same temperature, although only one receives sunlight. Researchers figured the planet must spread temperature in different ways. Recently, researchers were going over the decades-old data and studying the 45-hour convergence of the probe and Uranus when they noticed a 60-second jolt in its magnetic recording. It was discovered that Voyager 2 flew through a plasmoid, a giant magnetic bubble that might have been carrying the atmosphere of Uranus out to space. Actually, all planets leak atmosphere into space, and even Earth's atmosphere does the same thing. But don't worry, we have enough atmosphere to last billions of years. When Voyager 2 approached Neptune, researchers didn't think they'd see anything other than darkness. NASA crews increased the size of Deep Space Station's radio antenna in Canberra, Australia, to catch the incredibly weak radio signals that the probe was relaying from Neptune. On August the 25th, 1989, Voyager 2 was 30,000 miles away from the 8th planet in the solar system. Approximately 30 times farther from the Sun than the Earth, Neptune receives only 0.01% more sunlight than the Earth. In almost complete darkness, Voyager 2 started taking mysterious photographs. They revealed the makeup of the blue planet, showing the presence of methane, 6 new moons, and 4 rings. Like Saturn and Uranus, the rings and Neptune's 4 moons made a complex, interconnected system. The probe also discovered winds measuring 1,500 miles per hour around a strange, previously unseen place on Neptune named the Great Dark Spot, a massive rotating storm the size of the planet Earth. In fact, both planets, Uranus and Neptune, are known for strong winds that can reach supersonic speeds 10 to 15 times stronger than on Earth. Uranus and Neptune were originally thought to be gas giants, but in the 90s it was discovered that they were made up of heavier substances, and they became a distinct class of planets called ice giants. Triton was no less impressive. This moon of Neptune is located to the planet's north. It's the coldest of all natural bodies astronomers have discovered at a frosty -391 degrees Fahrenheit. Voyager 2 was able to approach the planet at a distance of about 25,000 miles and discovered active geysers that spewed nitrogen into space. Triton was the final object that the space probe would meet in the solar system before heading out into the great unknown. Where will the Voyagers go next? The Voyager's interplanetary missions have been completed, providing astronomers with lots of new knowledge and a better understanding of our solar system. These 2 probes, together, made huge breakthroughs in astronomy. Distant object in space made by humans, and Voyager 2 was the first to study the 4 outer planets, Jupiter, Saturn, Uranus, and Neptune, and also entered interstellar space in November 2018. But when Voyager 1 went into interstellar space, the instrument that measures the temperature of plasma had stopped working, but Voyager 2 still had a working instrument. Our Sun does a lot more than just provide light and warmth. The entire solar system is moving through space and is surrounded by a bubble called the heliosphere. This bubble is continually inflated by plasma coming from the Sun and is known as the solar wind. It extends 11 billion miles from the Sun's leading edge, surrounding all 8 planets and beyond. And a good thing too. Outside the heliosphere, in interstellar space, radiation levels and cosmic rays are a lot higher than inside the bubble. The Sun's solar winds are protecting the entire solar system as it flies through space. The heliosphere extends far beyond the region of Pluto until it encounters what is called the termination shock, where its motion slows abruptly because of the outside pressure of the interstellar medium. Voyager 2 discovered that the interstellar medium was at least 54,000 degrees Fahrenheit, but the plasma is so thin and diffuse that the temperatures around Voyager 2 remained extremely cold. The Voyagers have started supplementary missions to study the outer regions of the solar system in interstellar space. These two probes are still speeding across interstellar space and will never return to the solar system and only have the infinite reaches of space ahead of them. NASA's website shows where the Voyagers are in real time. On February the 9th, 2022, NASA's Parker Solar Probe took its first real images of Venus in visible and near-infrared light. The probe used its wide-field imager to capture the entire night side of Venus. NASA combined the images the Parker Solar Probe took as it flew past the planet and compiled a video. Here's what the Parker probe captured. The footage shows a faint glow on the planet's surface, the outlines of its continental regions, plains and plateaus, and even an incredible glowing halo of oxygen in the atmosphere. Scientists assumed the Parker Solar Probe would only capture the tops of the clouds that hide Venus, but it exceeded their expectations and was able to see the planet's surface through the dense veil of its atmosphere. According to scientists, due to the planet's incredibly high temperature, the rocky surface of Venus glows like a piece of iron pulled from a forge. Long before that, the USSR dreamed of landing their probes on Venus, but they had several unsuccessful attempts. Venera 4 and Venera 5 were the first USSR spacecraft that managed to transmit valuable information about the planet's atmosphere. They discovered that dense clouds in as many as 3 layers envelop Venus. And in December 1970, the Venera 7 became the first probe to soft land on the surface of another planet. Thanks to a powerful cooling system, it lasted 23 minutes under intense heat. With the help of measuring instruments, the probe transmitted detailed data on the temperature, pressure, and atmospheric density back to Earth. Meanwhile, NASA started launching missions to Venus. It's about Enceladus. It's covered in ice, but it shines like a lamp. Its surface reflects more light than any other body in the solar system. When Cassini approached the satellite, it made interesting shots against the background of the sun. They showed that Enceladus has its own geysers that eject water vapor and ice into space. The temperature at the South Pole turned out to be much warmer than originally expected. Enceladus was not so icy. The temperature in the south was enough to melt the ice and turn it into water. Scientists cannot give an unambiguous answer to the nature of the origin of this heat. At the moment, there are 2 assumptions. Either radioactive elements are hidden inside of Enceladus, or heating occurs due to the powerful gravity of Saturn. But this is not the most important thing. Another thing is important. Enceladus has water, heat, and organic molecules. And these 3 components are necessary conditions for the birth of life. Perhaps living organisms unknown to mankind are hiding just a few meters under the ice on Enceladus. They feed on dissolved organic compounds and reproduce by some kind of DNA analog unfamiliar to humans. Unfortunately, Cassini's cameras cannot see through the ice. Therefore, this mystery remains unsolved. Other expeditions will have to find out if there's life on Enceladus. In any case, this satellite is currently the most promising place for the search for extraterrestrial life in the solar system. Cassini's mission could not last forever. Since its launch in 1997, the probe has existed for 20 years. The last phase of its life was called the Grand Finale. It was a suicide mission for science. The Cassini probe made 22 flights between Saturn and its inner ring, sending priceless images back to Earth. And then it headed straight for the gas giant, broadcasting everything live. And it burned up in the atmosphere of the planet, fulfilling its duty to science until the last second. Thanks to the Cassini mission, we got incredible facts about Saturn and its moons. And perhaps we came close to the discovery of the first living form of life in our solar system. A new space project, Titan-Saturn System mission, is already being prepared. The exact launch date of the project has not yet been disclosed, but it's known that it will definitely happen before 2029. After launch, the new space project will follow the path of Cassini, and after 9 years, it will approach Saturn. This time, the mission will not be limited to photographs alone. Among the plans of scientists, there's even a task to send samples of Saturn's moons back to Earth. Perhaps this new mission will provide answers to the questions that we got thanks to Cassini. Here, among the Martian rocks and sand, is the final resting place of one of the most important robotic explorers in human history, the Mars Opportunity rover. The little robot was only supposed to last 90 days, but ended up exploring Mars for years, until one fateful day it would go into hibernation mode, sleep, and wait for a brutal global Martian sandstorm to be over. But the Mars Robotic Explorer would never wake up again. Get ready to discover the Opportunity rover's mission, what it uncovered on the Red Planet, and learn how the mission finally came to an end for our heroic little robot. On July the 7th, 2003, at 8:18 p.m., the Opportunity rover was launched towards Mars from Cape Canaveral, Florida. Its mission? To search for signs of ancient water that has since disappeared on the Red Planet. Opportunity was the second in a pair of identical Mars exploration rovers. Its twin, the Spirit rover, landed just weeks before Opportunity on January the 4th, 2004. The rovers each have 6 wheels, each with its own electric motor on what's called a rocker bogie system, to enable and increase mobility. The rovers stand 1.5 meters tall, measure 2.3 meters wide, 1.6 meters long, and weigh around 180 kilograms each. On January the 25th, 2004, after traveling from Earth for 6 long months, the Opportunity rover landed on Mars in a capsule shaped like a tetrahedron, which had airbags on all sides that inflated before landing. The rover capsule bounced at least 26 times before coming to a stop in the center of its small target center. NASA called the landing an interplanetary hole-in-one and nicknamed the spot Eagle Crater. The crater is an area called Meridiani Planum, an extraterrestrial plane where mineral deposits could be evidence there was once a lake inside the impact crater. It was time for Opportunity, nicknamed Oppie, to unfold itself and begin operations. The first thing on the list would be snapping images of the surface of Mars that researchers back home were eager to see. The Mars rover would get to test its PanCam camera setup to scan the horizon of Mars and take images of landforms that could have been shaped by ancient oceans or rivers. The panoramic cameras, or PanCams, are a pair of high-resolution color stereo CCD cameras. Each camera eye has color filters on rotating wheels, allowing certain colors to be selected for imaging, and the two cameras sit about 12 inches apart. These two little cameras are small enough to fit in the palm of your hand, but can create panoramic images as big as 4,000 pixels high and 24,000 pixels around. The PanCam can swing up and down 180 degrees and rotate a full 360 degrees to grab panoramic views of the Martian landscape. But the rover would first use its navcams to grab this image of Eagle Crater shortly after it had landed. The rim of the crater is about 10 meters from the rover. The size of the crater itself was estimated to be 20 meters in diameter. You can see the rover's mast, which had not been raised yet, and its dust-free, pristine solar panels. On the horizon in the photo, you can see the brighter hued rocks on the wall of the crater. Once the mast with the PanCams was raised, NASA got an amazing image back from the rover showing the inside of the crater, this time using the color filters. You can see in the middle left of the photo the indentations of the Martian soil from the now deflated airbags. On the 20th Martian day of the mission, the world would get the view of a sunset from another world, captured by Oppie's left panoramic camera. On the rover's 24th Martian day exploring the surface, the panoramic camera took this image, showing Opportunity's empty lander. NASA named this Challenger Memorial Station in honor of the Space Shuttle Challenger astronauts. The image is a mosaic of 12 different color images using the camera's red, green, and blue filters, which are set to approximate the colors the human eye would see. Now there's a big reason why the cameras are designed this way. When looking at images like this one in false color, the differences in surface materials are more visible and easier to identify. The rover snapped its first 360-degree image composed of 225 frames and shows the eerie landscape of Mars. Opportunity was taking a lot of fantastic and breathtaking photos, But was it going to find evidence of water? It turns out it would. And on March 2, 2004, Opportunity discovered what it was sent to find. Scientists announced that the rock outcrop the rover explored was once covered in water. On March 18, 2004, the Opportunity rover ended up proving, without a doubt, that Mars once had a lot of liquid water. This image shows what NASA researchers named blueberries, hematite spheres that were formed in the presence of water that contained iron. Then, in late March 2004, Opportunity left its landing spot and headed towards Endurance Crater. Scientists wanted to study the bedrock layers at the crater to figure out how long this part of Mars was wet. A strange image taken by the rover on October 7, 2004, shows a weird, lumpy rock formation that researchers named Wapme on the lower slopes of Endurance Crater. No one is sure how these bizarre rocks were formed, but one idea is that the impact caused them, and another theory is that water soaking the rock dried up and caused their deformed look. One of the rover's most interesting finds was rocks that were similar to meteorites found on Earth. Opportunity had a rock abrasion tool that it could use to drill into rocks to discover their composition. No one was sure if this was a meteorite or not. But on January 6, 2005, the Mars exploration robot would find the first meteorite ever discovered on another planet. OPI's spectrometers scanned the basketball-sized meteorite and discovered it was mostly made of iron and nickel. And this is not all the strange and interesting things it would discover. In 2010, Opportunity was snapping some images high up on a ridge of where it had previously traveled when it looked back to snap a Martian dust devil twisting through the valley below it. One of the more ominous images that Opportunity grabbed was this one, taken on March 20th, 2014. OPI is looking away from the sun into Endurance Crater and sees its shadow. But with all this exploring and traversing a wasteland, things can get dusty on the Martian plains. During the first week of January 2014, Opportunity would use its pan cams again and grab a self-portrait of its solar panels, showing a lot of dust covering the panels. Not bad, considering it had been there for 10 years. The panels looked nothing like when the rover first landed, but the little robot continued on. A big day for Opportunity would come in December 2011, when it discovered a vein of gypsum, a mineral that forms in water. The vein wasn't very big, only as wide as your thumb and 30 centimeters long. However, this was the most powerful piece of evidence that liquid water once existed on Mars, and that the planet could have been potentially habitable just like Earth. Opportunity had found evidence of water before, but those discoveries were in sandstones, and this was definitely proof of ancient water. To celebrate its 5,000th day on Mars, in February 2018, OPI used a microscopic imager camera on the end of its robotic arm to take a series of images that were stitched together in a self-portrait. It shows the rover at a place called Perseverance Valley on the slopes of Endeavour Crater. It's not a very good image because the camera is a fixed focus camera that was designed for close inspection of rocks and Martian soil. At this time, everyone was surprised at the record-breaking robot's longevity. But the solar panels were already covered in a lot of dust, as engineers saw in previous selfies. But in late May 2018, project scientists knew that a dust storm on Mars was going to be a big one, yet they had no idea how big it would be. Once every 5.5 Earth years, there is a huge dust storm on Mars. By June 20th, 2018, NASA announced the dust storm had gone global and evolved into a planetary encircling dust event. This storm was huge and created enough dust in the Martian atmosphere to completely blanket the entire planet, which blocked out light from the sun. Not only was the Opportunity rover affected, but orbiting satellites with atmospheric instruments could not see the red planet. Most of Mars's features were now hidden under a planet-wide opaque beige dust cloud. Opportunity would grab some more images before the sandstorm hit and take these stunning panoramic photos of its surroundings. These are photos of the desolate Martian landscape Perseverance Valley, the very last thing the rover would see, and what would end up becoming a robot graveyard. Just 10 days before this monster storm, Opportunity had sent data indicating the storm was lifting massive amounts of dust all around Endeavour Crater where it was studying and turning day into night. OPI would grab one more image just before it powered off and snapped this photo, showing Mars almost completely dark. The rover's batteries were low on power at this time, and minutes after receiving this data, the solar-powered robot geologist shut down, went into hibernation mode to ride out the storm, and hopefully recharge its batteries to reawake after it was over. But that never happened. The Martian dust that forms beautiful patterns on the planet's surface would end up being lethal for the robotic rover. The storm started to die down in late July, and by mid-September, it subsided enough for NASA engineers to try and contact Opportunity. They spent the next 8 months and sent over 1,000 commands to try and wake up the robot. But on February the 13th, 2019, with some sadness and tears, NASA announced the Opportunity rover was dead, just a day after the final calls to wake Oppie up went unanswered. Kind of a sad story for our robotic explorer, but what a success the mission was. Opportunity was the longest-lived rover ever sent to another planet and explored the red plains of Mars for more than 15 years, snapping photos and revealing clues and evidence of the planet's watery distant past. The rover had traveled more than 32 kilometers, its progress seen best on this map, with the US Washington, D.C. state shown for scale. And by the way, you might be wondering what happened to Opportunity's twin. The Spirit Mars rover stopped communicating with NASA on March the 22nd, 2010. The robot got stuck in a sand trap, and its batteries eventually died. However, it also made it past its original mission warranty of 90 Martian days and lasted 2,200 sols or 2,266 Earth days. Both rovers opened a treasure chest of discovery on Mars, proving that the planet once had water and laying the groundwork for future missions to Mars, including picking out landing sites. Together they returned 342,432 raw images and traveled nearly 53 kilometers, showing us what being on another planet looks like. All we can do now is thank these little robots for their service. Perhaps future manned missions to Mars could recover these two robotic heroes. Without the sun, no life on Earth would be possible. But this gigantic ball of hot plasma can also threaten us. Its bursts of radiation, also known as solar flares, and its explosive ejections of plasma called coronal mass ejections, accompanied by intense magnetic fields, can be frightening. Even though the sun's activity causes spectacular auroras on Earth, spacecraft, satellites, high-flying aeroplanes, and even astronauts can be in danger. Because of solar storms, our telecommunications, navigation systems, and power grids can fail to properly operate. We haven't been able to understand the sun and how it works, or when it's going to throw a massive ball of fiery plasma our way. This is why scientists have long dreamed of studying our star from a close distance. We know that the solar wind is a constant stream of charged particles that gains enough speed to escape the sun's outermost layer, the corona. But we don't know how energy and heat move through the corona and what accelerates solar energetic particles. Astronomers have been seeking the answers to these questions for 50 years, but to no avail. Finding answers meant sending a spacecraft through the corona that reaches about 1.1 million degrees Celsius, and it seemed impossible to accomplish until recently. This is what the Parker Solar Probe was made for, and it's truly a marvel of human technology. The first American spacecraft to fly by and study Venus in 1962 was the Mariner 2 space probe. The data received turned all ideas about the Earth's twin upside down. The probe showed a desolate, red-hot world with temperatures reaching 900 degrees Fahrenheit. The thick atmosphere of Venus was found to consist of corrosive sulfuric acid and carbon dioxide, and the atmospheric pressure 9 times greater than Earth's, enough to flatten any ship. The first close-up image of the planet was sent by the Mariner 10 probe in 1974. The image was edited to show what Venus would look like in color as seen by human eyes. It shows thick clouds of carbon dioxide that envelop the red-hot planet. And the Venera 9 and Venera 10 probes took their first images directly from the planet's surface, landing a few days apart in October 1975. To prevent the cameras from going out of service immediately, they were placed inside the ship in a protected compartment. Through a special porthole, light from the surface reached the periscopic device, which then directed it to the camera. The images lacked detail and appeared in black and white because the color cameras could not withstand the high temperatures and pressures of the planet. But for the first time, people could see the surface of a world located 61 million kilometers away from Earth at its nearest. These were the last images of Venus taken by the Soviet probes. But the photo shoots of the planet were just beginning. In 1989, the US launched the Magellan spacecraft, which brought us many vivid images of Venus. They show the ancient volcanoes of the planet, unique meteorite impact craters, and incredibly huge mountains. The tallest of them, Maxwell Montes, is 11 kilometers high. To compare, Mount Everest is just 8.8 kilometers high. The dark crater to the right and above the center is called Cleopatra, and the black stripes in the image are unmapped places. Among the areas of Venus shown by the Magellan, there's something breathtaking. Located in the Estler region of Venus, this is a volcanic edifice 66 kilometers across the base. There are also some incomprehensible lines across the terrain. These are tesserae, tectonically complex units that occupy about 8% of the surface of Venus, commonly occurring as high-standing crustal plateaus that are embayed by lava flows from the adjacent volcanic plains. So far, such patterns have only been found on the surface of Venus. And here's another unique area of the planet with a diameter of about 300 kilometers. A large circular structure near the center of the image is the giant Ain Corona, a volcanic formation about 200 kilometers in diameter. Coronas are unique ring-shaped structures on Venus. They were formed by plumes of red-hot rock flowing from deep within the planet through the mantle and crust. Not far from the corona, there's something else, a so-called pancake dome, approximately 35 kilometers in diameter. Unusual in appearance, these pancake domes are generally a few tens of kilometers in diameter, approximately 1 kilometer high, and are remarkably circular in shape. Scientists say they were formed by ancient eruptions of an extremely viscous lava. The planet first seemed to be devoid of internal energy, but it turned out to be quite active. Tectonic activity may still continue in the depths of Venus, and volcanoes could still spew lava on its surface. This is the volcano Mat Mons. Although it's not an actual direct image, the Magellan spacecraft couldn't see the surface of Venus through the thick layer of clouds, but its onboard radar surveyed the planet and transmitted the results to Earth. Here, a computer generated stunning views of Venus based on the received data. Mat Mons is the tallest volcano on Venus, 8 kilometers high, and scientists suspect a recent eruption. You can see a huge crater in its center, and a chain of very small craters scattered around the area. The images are incredible, but what about this talk of possible life living in the clouds of Venus? Astronomers have long speculated that Venus's clouds might be home to microbes. Unlike the incredibly high heat on the planet's surface, the temperature in the Venusian high clouds reaches a comfortable 30 degrees Celsius, although these clouds also contain about 90% sulfuric acid. Scientists at the Massachusetts Institute of Technology are now looking for supermicrobes in the planet's clouds. But NASA is planning on launching 2 more probes, the Da Vinci and Veritas missions, to try and uncover more about Venus, and the European Space Agency will send the Envision orbiter to the planet. Russia is also preparing a project called Venera D. Roscosmos plans to send an orbiter and a lander to Venus, and it's hoped that the lander will be able to withstand the harsh environment for an entire month. The orbiter and lander are expected to transmit many images of Venus to Earth in visible and near-infrared light. To allow us to see deep space, the creators of the Hubble Space Telescope had to work hard. The need for an orbital observatory was discussed back in the 70s. Scientists wanted to get clearer images of deep space than those taken from Earth. Our atmosphere makes observations difficult by absorbing and distorting light. We're going to show you some more incredible images, but first, a little quick history of Hubble. In 1977, the US Congress authorized the construction of a space telescope with the help of NASA. They decided to name it after the outstanding astronomer Edwin Hubble. The most difficult thing was to make the huge observatory mirror. It was constructed of heat-resistant glass with incredibly thin but durable coatings. A layer of aluminium 65 nanometers thick, protected with a magnesium fluoride layer 25 nanometers thick. The entire space telescope turned out to be nearly the size of a school bus. Its primary mirror has a weight of 827 kilograms and has a diameter of 2.4 meters. This mirror captures light from a space object and reflects it onto a secondary mirror 0.3 meters in diameter. The smaller mirror was placed in the optical tube. It reflects light through a hole in the main mirror, forming an image in the telescope. From there, it's sent to scientific instruments. At the time of Hubble's launch, there were 6 such instruments. These are wide-angle and planetary cameras equipped with a set of 48 light filters to highlight light spectra. The wide-angle one has a large field of view, and the planetary one made it possible to greatly increase the observation points. Another device, a high-resolution spectrograph, was designed to operate in the ultraviolet range. With its help, the telescope can see dim objects captured by a special camera. The high-speed photometer can observe variable stars and other objects with varying brightness, and the fine guidance sensors record changes in the position of the object. Scientific instruments were located in the tail section of the HST. Closer to the center, there are 6 gyroscopes designed for the telescope's maneuvers when pointing at an object. In addition, 4 reaction wheels allow the Hubble Space Telescope to change its overall orientation and catch a target. 2 main computers were placed in the central compartment. The first one is designed to give commands to the devices on board and transmit data to Earth. The other one has to control the guidance, gyroscopes, and other system functions. The telescope was also equipped with 2 wing-like solar arrays measuring 12.1 by 2.5 meters each that convert solar energy into electricity. And part of this electricity powers the operation of the telescope. The rest is accumulated in the onboard batteries for the period when Hubble is in Earth's shadow. However, the telescope consumes an average of only 2,100 watts of power per day, which is about the same as 5 refrigerators. In doing so, it revolves around the Earth at a cruising speed of roughly 27,350 kilometers per hour, which results in one orbit every 95 minutes. In order for Hubble to always stay in touch with the Earth, 4 antennas were placed in the area of its wings. All information and commands are transmitted via satellites. Astronomers were thrilled for Hubble to be ready for the launch. Finally, in 1990, the Space Shuttle Discovery took off with the telescope, which weighed about 10,800 kilograms. That's about as much weight as 2 full-grown African elephants. The ship safely delivered the heavy payload to a low orbit, about 550 kilometers above Earth. Shortly, scientists received the long-awaited images, and instead of applause, they got back a bunch of blurry images. Hubble's large mirror clearly had an optical defect. There was an aberration 1/50th the thickness of a human hair, but that was enough to affect the clarity of Hubble's early images. Spacewalking astronauts fixed, maintained, and upgraded the telescope during 4 servicing missions. Hubble has been scanning the universe for over 30 years, and it's constantly surprised us because the telescope is about 10 billion times as sensitive as the human eye. Even though Hubble captures everything in black and white, scientists later transform these images using a technique that mimics the natural perception of color by human eyes. Let's take a look at the most stunning of the million-plus images captured by the telescope. This is the Butterfly Nebula that lies between 2,500 to 3,800 light-years away. NGC 6302 received its name from the dying central star within the nebula. The star is exceptionally hot and shines brightly in ultraviolet light. The gas wings of the butterfly are about 20,000 degrees Celsius, rushing across space at over 965,000 kilometers per hour. Another Hubble image shows a blue light stream of electrons and other subatomic particles at the center of the M87 galaxy. Particles, attracted by a huge black hole, are accelerated to velocities near the speed of light. A monstrous black hole at the center of M87 swallowed up matter 2 billion times the mass of our Sun. The image of the Pillars of Creation in the Eagle Nebula is considered a symbol of our universe's beauty. These heavenly pillars of clouds of gas and dust look like they've been created by some higher power. Their bizarre silhouettes are illuminated by intense ultraviolet radiation from young massive stars that have accumulated around the pillars. Meanwhile, the cocoons inside the pillars, hidden from our view, are already forming new stars. And these 4 incredible space objects were discovered by Hubble almost simultaneously. The telescope captured a very tadpole-like galaxy, UGC 10214, 400 light-years away from Earth. Approximately 100 to 200 million years ago, the galaxy collided with a smaller neighboring galaxy and stole from it a long tail of stars and gas. The tadpole galaxy floats across space with 6,000 other galaxies in the background. Another image shows a spectacular collision between 2 spiral galaxies dubbed the Mice. Eventually, they'll merge, and the same fate awaits the Milky Way and the Andromeda Galaxy. Closer to Earth, Hubble imaged the amazing Cone Nebula. It looks like a rocky mountain peak, like a giant space mountain. Of course, instead of solid rock, it consists of cold gas and dust. Hubble has even peered into a celestial maternity ward called the Swan Nebula, or M17. The illumination comes from the formation of stars where the seeds of planetary systems are hidden. The bright lights in this image resemble the lights of a night city. This is what the galaxy cluster Abell 370, located 4 billion light-years away, looks like. Entangled among hundreds of galaxies in this interstellar nursery are mysterious arcs of blue light. They were created by light-distorted images of the most distant galaxies, located behind the bright ones. They're too faint for Hubble to capture them directly, but the cluster's gravity acts like a huge lens that magnifies and stretches images of background galaxies. Something similar can be seen in a house of mirrors. Due to the effect of gravitational lensing in the cluster, numerous copies of almost 100 distant galaxies have appeared. The most stunning example is the Dragon. There are several duplicated images of this spiral galaxy stretched along an arc. The following image is unique in that it largely confirms the existence of mysterious dark matter. For astronomers, this picture is priceless. The cluster of galaxies CI 0024+17, which lies 5 billion light-years from us, is surrounded by a mysterious ring-like structure. Scientists believe that a long time ago, there was a collision between 2 gigantic clusters. During such an event, clusters of an enormous size cannot be held together by the gravity of their own stars. So this could be dark matter which eventually clumped together and formed a ring. Usually dark matter, consisting of elementary particles still unknown to science, is invisible. But distant galaxies in the CI 0024+17 cluster illuminated its cloud with their radiation. And finally, you'll see what the universe really looks like. In 1995, astronomers decided not to aim the telescope at a galaxy or a star as they would usually do. This time, they chose a piece of dark sky over the constellation Ursa Major as their target. Make a circle the size of a dime with your fingers and look up through it. This is the field of view Hubble had at the time. And this was enough for the telescope to make a revolution in astronomy. Hubble was able to detect over 1,500 galaxies at various stages in their evolution. Some of them probably formed at the beginning of our universe's formation. This is how the Hubble Deep Field was created, but it didn't end there. In 2004, based on the first version, the Hubble Ultra Deep Field image was made, containing an estimated 10,000 galaxies. The snapshot contains galaxies of various ages, including the most distant red dim galaxies. Scientists believe they were born during the infancy of our universe, when it was just about 800 million years old. Then, in 2012, astronomers unveiled the Hubble Extreme Deep Field. It was assembled by combining 10 years of the telescope's data. Over 2,000 images, containing even dimmer and more distant galaxies than before, were taken by the near-infrared camera and the advanced camera for surveys. Later, even more galaxies were added to the image. Will Hubble be able to further improve its picture of the universe? Nobody knows for sure. The telescope is old. In the summer of 2021, it went offline for a month due to a failure of the main computer. And after a few months, there were problems with the synchronization of internal messages. But the problems were fixed from Earth. The observatory has also been repaired and upgraded 5 times in space. But even though it's in low orbit, no further missions are planned. So there'll be no one to repair the telescope in case of a malfunction. But even without serious issues, it can still fall back to Earth. During previous Hubble maintenance missions, scientists equipped the telescope with more tools, such as ACS and NICMOS cameras. So with age, this piece of machinery gained about 1,350 kilograms in weight. The excess weight and the state of free flight gradually shorten the orbit of the observatory and bring it closer to Earth. To prevent a catastrophe, astronauts prepared a device to decommission the telescope. If necessary, it'll be allowed to deorbit and fall into the Pacific Ocean. Or it could be sent deep into space. But for now, no one is in a hurry to say goodbye to the unique telescope. Engineering research gives Hubble a chance to keep functioning until 2030 to 2040, even without repairs. If this is the case, Hubble will have time to work in tandem with the next generation James Webb Space Telescope. Webb is able to observe the universe in infrared light, but Hubble is stronger in the optical and ultraviolet range. Both telescopes would be able to study the same objects or phenomena from different angles. But no matter how events unfold, Hubble's groundbreaking images will never be forgotten. The telescope has allowed us to see galaxies at all stages of their evolution and discovered protoplanetary disks, distant stars, exoplanets, and black holes. It showed that space is not empty and black, but bright and full of celestial bodies. Hubble even did the impossible. It sent us to the universe as it was 13.4 billion years ago. Did you know that right now, while you're watching this video, a huge eye of the telescope is watching the depths of space from Earth's orbit? And you can even join in on Space Telescope Live right now. You'll find the link in the description section. We hope you enjoyed the video. Let us know what you thought about it in the comments, and make sure to stay tuned here for more exciting stuff from our universe. Thanks for watching.